Hi there, my name is Geert van Geest. I am a bioinformatics trainer at the Swiss Institute of Bioinformatics, and in this presentation I will introduce our new resource, glitter.org, and hope to share with you how it encourages reuse and co-development of fair training material. Let's start this presentation with a story. A story when I was an MSc student, so that's already a while ago. And I was doing my MSc thesis at the Max Planck Institute for Plant Breeding Research in Cologne. And during that thesis, my job was to perform a genome-wide association study on potato. So I had to do a lot of statistical tests, actually tens of thousands. And of course, I also wanted to do some nice visualizations. So both of these things wouldn't be possible with the skills I had back then, which were basically Excel. So I had to learn some programming. Very lucky for me, the Max Planck Institute offered courses in R, introductory courses in R, that allowed me to get to know programming a bit. This course really was career changing for me, because since this course I started to learn more programming languages, I started to learn to program more often, and actually at some point in my career I could call myself a bioinformatician. So this course was very important for me, and it was a very nice course. It was very nicely done. So later on, about 5 years later, I started working for a company called Deliflor, and then my boss, he was also quite enthusiastic about using programming and everything to do all kinds of specific things with data. So he asked me, Geert, can you please teach these programming languages to other colleagues of you, so more people can use it? And I thought, okay, that is great, because I've had this course that was really career changing for me, so wouldn't it be great if I can offer the same thing to my colleagues? What you might already guess is I had to go back 5 years from then on my computer. I tried to find back these teaching materials in order to reproduce that for my colleagues at Deliflor. Unfortunately, I couldn't find the training material anymore. The person responsible at Max Planck probably wasn't working there anymore. So actually I had to redevelop something myself, which was a real pity, because there was already very nice training material available. So the idea of the story is that, the message of the story is that we create great training material all the time. We have great teachers among us, great training material developers among us, but very often we do not have really reuse in mind. Usually we create training material for a specific course, and once that course is done, we do not really look much further. Which is a real pity, of course, because it limits, for example, your learners to find back material. Although you might have handed out, for example, PDFs with exercises and everything, learners tend to lose those things, for example, and they want to be able to go to a resource to actually find back that training material, which is often not possible. Secondly, you also limit your colleagues. For example, if you are gone or you cannot teach for whatever reason, you won't be around forever, right? So your colleagues will not be able very well to reuse your material to also teach that course. Thirdly, you also limit yourself. If you do not make your course material reusable, it might become very difficult even for yourself to reproduce the course you have been given before. And lastly, of course, you also limit the scientific community. A lot of us are doing a job that is publicly funded, so basically paid by the taxpayer, and we kind of owe it to the scientific community to set steps in their building of knowledge and skills that's also based on material that's developed by you. If your material is better reusable, you serve the scientific community better. So what's in it for you, making your training material reusable? So you make things easier for the future you. So maybe a few months, a few years from now, you want to reteach a specific course. And then if you make your training material more reusable, it is much easier for you to, again, teach that course, because, yes, you will forget things. Secondly, it will kind of force you or encourage you to adopt standard practices. So because if you adopt standard practices of developing course material, it will become more reusable. However, that's also an advantage for you because then you can use material of others much easier in your course material. Thirdly, by making your course material more reusable, you can kind of build communities around your course material because people will be more likely to reuse material, maybe come back to you with feedback, or maybe even start co-developing the course with you. Also related to that, by making your material reusable, it is quite likely to get feedback, and therefore you will just plainly improve quality of your course. If you approach this in a more technical way, so what kind of file format should we use, or how should we store our training material in order to make it reusable, it might make sense to actually compare your training material or training material in general to software, because like software, training material is a collection of files, formats, and dependencies. So you have all kinds of different file types in there, like software, and very often you are developing it continuously. So you give multiple iterations probably of the same course, and it improves in quality or changes with every course instance. And typically you also give a course with multiple people together. So it's usually a kind of a community that creates course material. And the same thing counts for software very often. Also, software is often developed by multiple people. If you think about how to store and share software, if you have a bit of experience with that, immediately Git and, for example, GitHub come in mind. And that makes sense because they are ideal places to co-develop and share software. Git really stimulates the reuse because how people work with it is with Git, and how you have to work with Git is very transparent. It very much encourages collaboration and therefore also fairness. So software lives in these Git repositories and are stored in GitHub or in GitLab, for example. Can we do the same for training material? And I guess you can guess the answer, and that is, of course, yes. It has actually a lot of advantages to store training material in Git repositories. One big advantage is that all related files are typically in one place, so it is much easier to understand the context of all these different file types if they are in one place and they're interrelated to each other. Secondly, of course, Git repositories come with version control. That's the main idea of using Git. And that comes with a lot of advantages. For example, it's easy or straightforward to do something experimental. Sometimes you just think, okay, I'm just going to try something out. I'm just going to try this new exercise, for example, but I don't want to destroy the rest. But with Git, it's actually quite easy to do something experimental, merge it later on with the main training material, or just say, okay, this is not going to work, I'm going to destroy this part. It also is much easier for collaboration because multiple people can work on the same set of files without breaking each other's things. Also, a nice advantage of using Git for training material is that anybody can host training material. So you do not have to be in a specific institution that has done a specific investment in a certain platform. For example, now everybody can use GitHub, everybody can use GitLab, and you can start hosting your own training material entirely for free. And also anybody that is not necessarily within a certain institute can contribute to any repository. So that makes it very easy to use with a very diverse group of people. Also, a nice feature about Git and GitHub and GitLab is that you have nice task management tools that makes you work quite efficiently. And lastly, and that's actually the reason why a lot of people use GitHub or GitLab to store their training material, is that you can host very nice looking websites. So in the repository, you have the source files for these websites, and you ask GitHub or GitLab to actually translate it into a website and host it and have your exercises or presentations or whatever training material online available to your learners through the website, so they can approach it through the browser. Alright, so I wanted to tell you a second story. This story takes place, it is 10 years later, so 10 years after I did my master's thesis at the Max Planck Institute. And when I was working as a trainer for the Swiss Institute of Bioinformatics, I'm also teaching single-cell transcriptomics, and there is a small community within Elixir, the single-cell omics community, and we had a workshop specifically for single-cell trainers with this community. The idea was to exchange training material during that workshop, and that was actually super nice for me because we were just developing some single-cell transcriptomics training material, and it was super nice to see all of these different materials of all these different trainers. Nice thing about all of these materials, actually all of them, were stored on GitHub. So it was relatively easy to use that material, reuse the material. But on the other hand, I was quite amazed that I had never heard of a lot of that material before because I just wasn't able to find it on GitHub. So I started generating a list of those single-cell courses. Later on, I figured, why would we focus only on single-cell transcriptomics courses? I can also add other courses there, all courses on GitHub to a list. At some point, I published this list, which was also stored in the GitHub repository, of course, on social media, and I got really a lot of very positive response, which kind of surprised me. But looking back, it didn't really surprise me that much because it is so difficult to find all this training material on GitHub. So really a lot of people were looking for such a list of all of these very nice courses that are available on GitHub but are very difficult to find. So as I was trying to, the message I tried to get across when I was telling this story is that a lot of great material on GitHub and GitLab, but they are not very findable. And one reason for that is that GitHub and GitLab are simply not developed for finding repositories. They are there to host repositories, to make them private, for example, and to associate them to organizations or persons, but not to just find a specific repository out of the blue. Related to this is that metadata of repositories, also with training material, but also often with software, depends very much on the author. So how good this annotation is describing what is in a repository depends very much on the author, and it is not very standardized. However, we do have other information, for example, the activity of a certain repository, if somebody is currently working on the repository, so how recent it is. We can also get information about popularity, for example, the number of bookmarks, which are the GitHub stars we can get from GitHub and GitLab. We can get information about the owner and who is contributing to that repository. So although there's not a lot of metadata what's in that repository, we do get a lot of data about popularity and who's owning it. Typically, and that occurs quite often, is that people do add a license, and that's in a way kind of standardized both with GitHub and GitLab. And there is very often an associated website. So for example, the website where the training material is approached by the learner is often also specified in the repository. So with this in mind, so not GitHub and GitLab repositories with bioinformatics training material are not very findable. However, but we can get a lot of information out of it. We started developing glitter.org. So what is glitter.org? It is a platform that contains training material that is on GitHub and GitLab, so only on GitHub and GitLab. It's basically a list of repositories. Currently we have more than 330 repositories in there from more than 140 authors or organizations. So it has already very diverse set of repositories with training material in there. We curate them minimally, meaning that we do not assess them on quality, only on the fact whether it is bioinformatics training material, yes or no, and we annotate them based on a topic with a controlled vocabulary, because we think that very much increases the possibility somebody actually finds a course they are looking for. So what it allows you to do is that a user can search a repository based on topic, based on author, or other text that is in the repository, But also you can also sort based on popularity with these GitHub stars, these bookmarks, and you can even store or sort your list of repositories based on recency. So what is the number of days since the last time somebody actually worked on that repository? So in addition to being able to find repository based on topic, you can also find repositories based on quality, or at least popularity. What I also wanted to mention is that Glitter also comes with a REST API, so you can programmatically access the information that is in Glitter, and you can integrate that information, for example, in other websites or applications. So I would like to invite you to visit glitter.org by either scanning the QR code or just type glitter.org in your browser. Have a look on what's there, and if you have a repository that's not there yet, please click the big contribute button and add your repository to glitter.org.